else. But now we're going to go to Mr. Professional Jordan.
Thank you, Ray, for covering for me. So yeah, I work for a company called Nielsen. We're probably one of the largest companies in the world that sells the products of data science as the product we produce. And is this not going to work? Oh, there we go. Okay, so yeah. Global Measurement Data Analytics Company is the official phrase. Hundreds of thousands of data scientists, hundreds of data models. And one of the things that we see as a company that sells the products of data science modeling on the scale that we do is that we need to be rigorous. We need to produce models that are repeatable and defendable, because when those Nielsen numbers come out, if they're the Nielsen ratings or if there are packaged goods, if you're a brand manager, you really care about what those Nielsen numbers are, and we need to make sure we get it right every time. We have a different perspective on data science projects than I think most people have. Now, when you look at a data science project, you have four components. You have the data, of course. You have the math, the model. You have the management of the software development lifecycle, and then you have the infrastructure that you need to put the model into production, especially when you're dealing with gigabytes or terabytes or like in the even petabytes as we have in some of our data lakes. What we've done is we've taken a look at, okay, we have a lot of data scientists, they're really good at this modeling part, but they're not so great at all the other stuff. And the other stuff takes a whole bunch of time and costs a lot of money. So what we want to do is build a platform that takes the stuff that's not the modeling, that's the data, that's the development of the software, that's the pushing the data, the models into production, and bundle those into a single product that can take care of all that for the data scientist. And that's the product that I'm working on and Joe's working on and some of the other people here. So we have a couple other motivations. I'm just actually going to blast it really fast. So, another thing is we have all these models, we're producing them and we're publishing them. We want to go from having lots of data scientists grinding away on spreadsheets to being syndicated models that can sit there and run monthly or weekly with no human intervention. We want to move from waterfall development methods to more agile methods for these models where, we sit there and we say, okay, we're gonna, we see market opportunity here. We're gonna produce this model, put it into production quickly, and without a lot of handoffs between teams. We want to move from, Nielsen's a big company. We've been around for 95 years. We have stuff like mainframes. We have SAS grids. We want to move towards, for instance, Python, modern technologies. And then finally, we want to move from proprietary, like SAS grid I just mentioned, to open source technology. So that's pretty much what the product that we're building is, and what we have built is. I can go through really quickly what the architecture looks like. This is like, I guess, the stack of icons. The important thing to recognize here is that this product is taking all these icons that you see and making them all work together on one platform that's running on Kubernetes. So this is actually an architecture model that I had to put together for a security review. This dashed line is the Kubernetes cluster. And then you can see we have all of our Airflow jobs, all of our Spark clusters. We have Jupyter Notebooks. We have the ancillary services. We have GitLab to manage the software development lifecycle. We have things like Superset to do. We do performance reporting when the users, when you run a model, you can sit there and see what resources it consumed. And we have all that stuff running inside the Kubernetes cluster. But then the key thing that we're doing, which I think a friend of mine just called it recently, Kubernetes as a service. Our platform is creating this cluster, and we put some of our services in here. But the workers, the Spark workers, the Airflow pods that are spinning up, these things are specified by the users without ever having to know anything about Kubernetes or write any deployment YAMLs or do anything like that. They just say, hey, I have this workload, it's a model, I want you to run it, and then we take it and do the rest. So I want to quickly show you guys one of the use cases, one of the models that's actually running on our platform. This is like actually the unified model was built concurrently with our platform, the Data Science Studio. And this was these are the design goals of the unified model. Basically what they have is this is a lot of jargon, so we have FMCPGs, fast moving consumer packaged goods, and then we also have marketing and media data sets that come from, you hear about the Nielsen ratings and all that kind of stuff. What they wanted to do with the unified model is take all those data sets and merge them together so that we can produce insights. For instance, we have products like business drivers that says, hey, like if you're in the business of selling shampoo and you have a series of things that might drive the sales of shampoo, the price, what promotions you're running in the store, etc. Well, maybe we can mix in media data and also say, well, let's look at the effects of marketing campaigns on these, on your business drivers. Or you can flip it around. You can look at some of our other products like marketing effectiveness. You can probably guess the marketing effectiveness is if you have a marketing campaign, what is the what portion of your sales are being driven by that marketing campaign? We can, with the unified model, pull it all together, and then we have one centralized model and a single source of truth, to do that. And then this is the architectural diagram of the unified model, which is all screwed up. So, it's just loading incredibly slowly. Okay, this is kind of crazy. I pulled this out of a deck for the data that the data scientists put together. And data scientists, as it turns out, are even worse at making slides than programmers are. So this is kind of brutal. The key point that's all missing here is everything that's actually happening inside a data science studio. So that's the part I wanted to show you. You're right. Oh, crap. Okay. Okay. Yep. Cool. Okay. So you can see, it pulls the media data. You have the product store data. We call it RMS data. You have all the facts that you have in those two data sets. You have the transformations that run, and then it finally pushes that out into the data lake. But that all happens inside the Data Science Studio. It's all in Python. It's mostly pure Spark because it's running on enormous data sets. And that's a model that was developed and is now running on our platform. So I wanted to just really quickly blast through what it looks like to actually use the platform. We have a Jupyter Notebook here. I'm exploring some data. I'm going to create a model. I'm using SparkML, and then I'm going to play around with it in my notebook. And now I want to productionalize it, so I'm going to turn it into an Airflow DAG. Then I run it, and this is a model I put together, and this is the thing that I always like to point out to people. So Data Science Studio saw that my model is using Spark, so we actually spun up the Spark cluster inside of Kubernetes, ran the model in Spark, and then when it was done, we turned the Spark cluster off because they're expensive to run in the cloud. And then I'm going to take a look at that superset dashboard and kind of see what resource consumption I had while my model was running. So this is just one of, I think, quite a few dashboards we have for introspecting how your model runs. So that's it, and like everybody else, we're hiring, so come talk to me if this is interesting to you.
Well, Jason comes up. There we go. One question. What do you got? Best question we got. We do the best. Just be a question. Right back here.
What's the biggest pain point transitioning from sort of the legacy proprietary systems to this open source ecosystem you built?
Yeah. So the question is, what's our biggest pain point? Honestly, so it's transitioning from legacy. Well, so the unified model is new. I'm kind of a bad person to ask about that because I'm building the platform. I'm not building the models. I can tell you one of our biggest pain points has been Azure. So we're running in Azure because we deal with, a lot of our customers are competitors of Microsoft or of Amazon It's just you have to do a lot of things to make the system resilient when it's running on a platform, underlying platform that's not resilient. So it's a pain point. It's also a lot of fun. So.
One more round of applause for Jordan.